Right, great. So thanks for joining. What we're going to do this evening is we're going to start the last learning unit, which is learning unit 9, and that's the chi-square distribution. So this section continues from the previous learning unit in that it's also a form of hypothesis testing, but you would use it to test different hypotheses. So let me share my screen and kind of give you an idea what it's all about. Okay, so I am sharing my screen. If you can't see it, just let me know. This is the problem we'll cover first. All right. So before we dive into this problem and I start reading through the question, I'll just give you an idea of what the chi-square distribution is used for. So sometimes you want to test whether two variables are related or have an influence on each other, or whether they're completely independent, right? And for example, do we want to check whether there's, let's see an example other than the one I'm talking about right here, is, does the different ice cream flavors influence customer sales, right? And that would be important because you want to know whether that does have an effect on the other, and if it does, then you know how to kind of change your business strategy, right? That could be like a poor example, but you also use a different one where is if you change certain type of content in your publications, does it influence the readership? Does it increase readership or not? And you want to test whether that they influence each other, whether they're associated with each other. So that's where you would use a hypothesis test to determine whether two variables are associated or they're independent, right? So this example is doing the same thing. What we're going to test here is whether there's an association between gender and your level of motivation, right, in a certain company. So, are males more likely to be highly motivated versus females and vice versa? So what we've done here is we've captured some data that we've put into this table. And what we have in the first row and first column is we have 8 males who are highly motivated. And then in the second column, we have 8 males who are moderately motivated. And then we have 14 of them which have a low level of motivation. And the same thing is done for females, right? So let's look at the first question here. Question A, it says, calculate a row percentage cross-tabulation table to show the motivation level profile for each gender and interpret each gender's profile by inspection. All right. So what we need to do is we need to make these numbers percentages because the raw numbers don't really give a fair comparison. And as you can see, there's a lot more females than there are males. So if you just compare the absolute numbers, it wouldn't be fair. But if you convert them to percentages, then you're comparing like with like. So for question A, and I'm just telling you this from past experience, and I'm not saying that question A is very unlikely to come out in the exam. I'm just saying from past experience, question A is not often asked, right? But I'm not saying that it won't be asked. Okay, so just keep that in mind, right? So it's A is just to kind of give you an illustrative example of whether, by eye, just by looking at it, can you determine whether males are more likely to be highly motivated versus females or vice versa. All right. So what we're going to do is we're going to create the same table, right? So what I'm going to do is I'm going to do the same table here. Question A is males. I'm just going to write M for males, F for females. Then we have a high level of motivation, we have a moderate level of motivation, and we have a low level of motivation. All right. So all we need to do is we need to make these numbers percentages. And what I mean by that is look at males just amongst each other. And just look at males only. The total of males is by adding up that 8 plus 8 plus 14. Okay, so if you add that up, I think you should get about 30, I think. Right, that's 22, 30, right. And all we need to do is, instead of writing 8 for 8 males that are highly motivated, we make that A as that 8 as a percentage. So in other words, we divide by 30, so it becomes 8 over 30. For moderate, it will also be 8 over 30. So we've got 8 there, and then below it will be 14 over 30. And we express that as a percent. So if we do that, and I'll just use one decimal, so it'll be 26.7%. So it'll be 26.7% here. And then below, it'll be 46.6%. And we'll do the same with females. Okay, so females, we have 19 of them who are highly motivated. Okay, and then the total of them is 31. It's about 40 of them. All right, so we divide by 40. Right, and then we convert that to a percent. So I'll do that for all levels of motivation. So I'll do 47.5%, and 30%, and it's 22.5%. And the total is 5. So now if you just look at the percentages, now we can compare like with like. And if you look at it, you'll see that the highest percent for females falls under high level of motivation. But for males, the highest value they have is low. So you can see here that it seems that males are more likely to have a low level of motivation versus females who are more likely to have a high level of motivation. Right? And that's what you can conclude by creating a table with the row percentages. I just hope that makes sense. If it doesn't, just let me know. Check the chat if there's any questions. Okay, no questions so far. All right. Okay, so let me clear this table, and now we're going to answer question B. So we've done A, and now we're going to do question B. Question B is the kind of question you'd very likely be asked in the exam. Okay, so I'm just going to clear this, and we're going to dive into question B. All right. So question B says, conduct a chi-squared hypothesis test to identify statistically whether there is an association between employees' gender and motivation level. Okay, so we're going to test if there is an association between employees' gender and motivation level. Okay, that's why I'm going to underline that. And we use a 10% level of significance. All right. So to do the hypothesis test is a question. I see there's unmuting. Okay. All right. So with the hypothesis test, as we did in the last learning unit, there's 5 steps. Okay, so it's the same here. There are 5 steps. Step 1, we're going to declare our null and alternative hypothesis. So we have our H0 and we have H1. All right. Now your H0, when you're doing a test of association or independence, it's the same thing. Your H0 is always the case that there's no association. So your H0, you can say, there's 2 ways you can try this. Okay, so you can say no association. And you will say what those variables are. And in our case, it's gender and motivation. Between gender and motivation. Level. Right. So H0 is simply just the opposite of that. H1 will just be the opposite of that. H1 will be there is an association. So if you already wrote the whole thing about gender and motivation level in H0, you don't need to say the whole thing again in H1. All you need to say is there is an association. Okay, all right. It just needs to be the opposite of that. So remember that, okay? When you're doing a test of independence or association, you will write no association between gender and motivation level, or you could also write gender and motivation level are independent. Okay, it's up to you. They're both the same thing. All right, you can write either one. And then H1 is there is an association. All right, so that's step one. Pretty easy. You don't need to say whether it's a upper tail, two-tail test, because for a chi-squared test, it's always an upper tail test. It's always an upper tail test, right? So that's going to bring us to step two now, is to find our rejection region. Step two, find the rejection region. All right. Now for the chi-square distribution, the shape of the distribution is not bell-shaped like what we used to in the past previous learning units. It's actually skewed like this to the right. So that means it's drawn out to the right like this. All right. It looks like that. I'm sorry about that. It's kind of like that. All right. And the rejection region is always on the upper right side. Yeah, so I'm going to shade that rejection region in red. And the size of the rejection region, as we learned from the previous learning units, it is given by your alpha, or your level of significance, which I've underlined here. So the size of that area is 0.1. So this red region is 0.1, or 10%. And now we need to find this value here on this axis, the critical value. And that's where we're going to use the chi-square table in the back of your textbook. Right, so I think I have it. Let me see if I have it here. There we go. This one. Okay, so in the back of your textbook, I'm going to paste this in the all right, table 3 in the back of your textbook. All right, you will see this graph here. Okay, now this graph and this table is what you would use for the chi-square distribution. Now, this alpha, if you look at this alpha on the top, on the right of this graph, it's telling you that that's the size of the area. The arrow is pointing to that area. So in our case, our alpha is 10%, 4.1. So now if you look at your table, and if you look at the first row, you will see that that's your alpha values. It's telling you that that's all your different alpha values. And we're looking for an alpha value of 0.1, which means it's the first column, because you can see there's a 0.1 in that first column. So we're only going to look at the first column, but which row do we use? Now the row is given by your degrees of freedom. So your degrees of freedom and how that's determined is by using this formula here. And just make a note of this, because this formula is not given to you. You need to memorize it. Can you memorize this? Your degrees of freedom is R minus 1 in brackets times C minus 1 in brackets. Now I'll explain what the R and C is. It's very simple. The R is just the number of rows that you have. So in our problem, we only have 2 rows, male and female. So your R is 2 minus 1 into C minus 1. C, if R is rows, C would be your columns. There's 3 columns. High level of motivation, moderate, and low. So there's 3 values for your column. So that's your C. Right, now if you work this out, okay, remember you use BOMDAS to do this. You do the brackets first, okay, and then you multiply. So if you do that, you'll get a value of 2, and that's your degrees of freedom. So now we know degrees of freedom is 2. If we go back to our graph, paste it here. Now, if you look at that, if our degrees of freedom is 2 and your alpha is 0.1, then if you look at your table, that means where DF is 2, that's the second row, and the first column where they intersect, you see the value 4.605. 4.605, so that's our critical value. I'm going to write that here. 4.605. So anything greater than this, we are going to reject H0. Otherwise, we accept H0. And that is your step 2. Check the chat. Okay, so far so good. All right. Just let me know if you have any questions. All right, so now we've got our rejection region. Now we're going to do step 3. Now, step 3 is the bulk of the calculations. Okay, it's going to take up most of your time doing this. You probably, out of the 5 steps, you'll be awarded the most amount of marks for step 3. It's very important you follow what I'm doing here. If you have any questions, you're not sure about anything, please let me know. All right, so I'm going to make some space. And let's do step 3. Okay, step 3. All right. Now for step 3, what you need to do is you first need to determine what are your expected frequencies. So the table that they give you, the data that they give you, that all those values in the table, that's your observed frequency, FO. Here we need to determine your expected frequency, FE. Now the formula to get FE is this, which I also ask you to memorize because this formula is not given to you. Your FE, your expected frequency, is given by the formula row total, okay, times column total all over grand total. All right. Now, maybe it seems a bit complicated, but when I take you through how you use it, it's actually very simple. Let's just look at, I'm going to reconstruct this table. Okay, so I'm going to write it here. Let's look at males. You got females. You got high level of motivation, moderate, and then you got low. All right. Now, what I'm going to do is I'm going to put the totals for this table here. In other words, I'm going to add up the row total. So the row total is 8 plus 8 plus 14. That is 30. And okay, instead of me writing it, let me just copy this because the writing would be a lot easier if it's text. You paste it here. Okay, so all I've done here is it's the exact same table that was given to us in the question, right? Except the only difference is I put the totals in. Okay, so you see here, I put the totals in. So 8 plus 8 plus 14 is 30, 19 plus 12 plus 9 gives you 40, and then I added going vertical. So if I add 8 plus 19 going down here, 8 plus 19, the total is 27, which is how I get the 27. And the same for moderate, 8 plus 12 is 20, 14 plus 9 is 23, and then the grand total is, you can either add up the totals here, 30 plus 40 is 70, or if you add up the total going this way, it'll give you 70. It's going to be the same thing. All right. So you need to create a table with these totals because you need it to use this formula here. All right. So let's look at the first entry here for male high. So what we're trying to do is we're trying to get the expected frequencies. So how I use that formula to get this value here is look at where we are in this table, right? We're here under male and high. So the row total, I look at this point here, the row total is travel along the row total is 30. Okay, so I'm going to use row total, which is 30 times. Now we're going to move to column total right here. Column total is, remember we are under male and high, the column total is 27. Go down column, total is 27. 30 times 27 divided by, now we're on the grand total. The grand total is always the same. It's everything added up. If you add up all the numbers in the table, it's 70. Okay, so that's the denominator. All right, now if you work this out in your calculator, you get a value of 11.57. That's your expected frequency for male and high. 11.57. All right, now let's do the next one. Now we're going to do the next point, which is here. Moderate level of motivation for males. So now we're at this point here. So here, the row total is still the same. It's 30. So it's still 30. But your column total now, if you travel down this column here, it's 20. That's your column total. It's 30 times 20 divided by the grand total, which is 70. And if you work that out, you get a value of 8.57. 8.57. All right, so I think you're getting the idea. It's very simple to use this formula. So let me ask you this question, okay? Calculate the expected frequency for females and low level of motivation using the same formula here, like what I just showed you. Can you give that a shot? Write the value out in the chat. Okay, so I'm asking you to work with this value here. What is the expected frequency for females and low level of motivation? So you would use this table and you would use this formula here to get it. Can you work that out? I'll give you a minute and give it a shot. Write that value out in the chat. In the meantime, I'll complete the other values for you. And see if anyone's got it. We'll try Ethan, but I think you're working out female and moderate. Yeah, that's right. That's right. 13.14. Very good. That's it. Please, everyone, if you don't understand, you're not sure about something, please let me know. It's very important that you understand this part here. Because if you get this wrong, then everything else is going to be wrong. So step 4 and 5. So this would be 13.14. Very good. All right. So these are your expected frequencies. All right. I'm going to check the chat one more time. Perfect. All right. Now, you've done this part. We've not done it step 3. I told you it is the bulk of the working, and it does take a bit of time. But if you just follow these steps, you'll be fine. Okay. So I'm going to make some space on this board. So what I'm going to do now is I'm going to rearrange this table. Okay. So we've done this. We don't need this formula now. I'm going to rearrange this table like so. Copy and paste it, and I'll show you what I'm talking about. Okay, so don't worry too much about the values for now. I'll explain everything in a second. Okay. All right. What I want to draw your attention to first is just focus on, let's look at this column here. All right. Here we have male and females. All I'm doing is I'm taking the row variables and I'm just writing over each of them. Now for males, you can have 3 levels of motivation. So that means for male, there's 3 columns of values for them. And that's what I'm going to write here. What are the 3 values for males? And in exactly the same way, there are 3 values for females, okay? Which is what I have here, high, moderate, and low. Now the observed column, observed is your F0, okay? That's what's given to you in this table. So all I'm doing is I'm just writing the values out in a different way, all right? So for male and high, the value is 8, so that's why I have 8 here. For male and moderate, it's also 8. Male and low, it's 14. Then we move on to females. For females and high, it's 19, which is why I have 19 here. And moderate is 12 and low is 9. Okay, so that's the first column. No calculation. All I'm doing is I'm just rearranging it in this way. There's a reason why I need to rearrange it this way. Okay, right? Because to calculate the value that I need to test the hypothesis, I need to arrange the values like this. The next column is your expected frequencies. In other words, that's your FE. And that's what we spent all this time working out here. These are your FE values. So in the same way, for male and high, I have 11.57, which is what I have there. For male and moderate, it's 8.57, and etc., all the way to the last value, which I asked you to work out, 7.14. Right? So that's the first 2 columns. No calculations, just rearranging it side by side. Right? So that's the first 2 columns. Okay. Right. The next column, and let's come back to here. Now, what I'm going to do is the next column, the formula for that is entitled this here. What that means is I subtract F0 and FE. So that means this value, which is F0, subtract FE. So in other words, 8 minus 11.57. So that's my F0. That's my FE. And this formula squares it, raise it to the power 2. So after I subtract it, I raise it to the power 2. And if you do that for the first value, for this first row, sorry, you'll get a value of 12.76. I do the same thing for the next row. For the next row, it's 8 minus 8.57, and I square it, and I get this value, 0.33. And I do this for every row going down. All I'm doing is I just follow this formula, F0 minus FE whole squared for each row. That gives me this column here. And in the last column, all I'm doing is I'm going to make the space here. In the last column, all I'm doing is I'm taking the values here, and I'm just taking that and dividing it by FE. So in other words, this value in the first row here, 12.76. Take that value and I divide it by the FE column here, which is 11.57. And if you do that, you get a value of 1.102. I do the same thing for the next row, okay? And so on and so on. I do that and I get all the values. Now what I've done in that last column, right? That last column, the formula for what I'm actually doing there is this. I'm taking the difference and subtracting, sorry, F0 and FE, squaring it, and dividing it by FE. All right, that's what the last column is. That's all of that calculation is to do this. this formula here. Right, now you've done it for each of them. Right, now there's a reason why I'm doing that. It's because in your hypothesis test for chi-squared distributions, you need to work out the statistic here. You need to work out this sum F naught minus FE whole squared divided by FE. That's what you need to work out. Now, if you look at what I have here and what I have in front of the summation sign, it's the same thing. It's the exact same thing. So that means I've worked out everything in front of the summation sign. So the final thing I need to do is I just need to sum everything up. If I sum all these values up, that will give me this entire formula here. All right. If I sum all of it up, that means if I add up all the values in the last column, I'll get a value of 5.0. 5 point. Then put it in a different color. 5.04. All right. If I add it all up, once I worked at 5.04, I've worked out the statistics. That's what this is. This is your statistic that you use to compare to your rejection region, your critical value. Does it fall in the rejection region or not? Right. This value falls in the rejection region, then we reject H0. And as you can see, 5.04 is bigger than 4.6. It's bigger than this value here. So that means it's on the right of it. So that means it falls in the rejection region. So that means we reject H0. Okay, we are going to reject H0. So it's here. Okay, so that's it for calculations. We're done with calculations for this question. So all that hard work is done. Now we just draw our conclusion. Okay, so that 5.04 is bigger than 4.605, that means it falls in the rejection region. So step 4, we reject it. All right, and so step 5 is this concluding. Now, if you look at what we've done, we are saying we reject H naught. So that means this is not true, and that this is what we're going to. So that means there is an association in the and motivation level, and we would write it out properly, stating what our significance level is. So at a 10% level of significance, right, we conclude that there is an association between gender and motivation level. And that is question answered. All right. So I know step 3 is a lot of work. I did say it is, but you are going to be awarded the marks for it. So question like this would be 10 marks in total. And step 3 could easily take up 5 marks, 50% of the marks. Let me check if there's any questions. All right, everyone all good? Okay, cool. So what you've done now is the chi-square test for independence. All right, so let me just put it on the board. For the chi-square test, just know that there's 3 ways you can use the chi-square test. In this course, right, there's the test for independence, which we've just done, or association, same thing. There's the test for equal proportions, and there's the goodness of the test. These are three ways you can use the chi-square distribution to test hypothesis. It's these three. 1, 2, 3. These two, the first two, are very similar. All right, they're almost identical in how you approach them. The only difference is step 1 and step 5, but everything else is the same. The chi-square goodness of PERT is quite different, and I'm going to leave this one for the next session. So we're not going to do this now. We're going to do this in our next synchronous session. But because 1 and 2 are so similar, all right, we can complete them now because the workings and the calculations are pretty much the same. All right, it's just the way you interpret them that are different. So we've done this already. Right? We've done this now. And now we're going to do the test for equal proportion. So we're going to do this one now. All right, so let me clear this board.
Sorry, sir, just out of interest, in terms of the way that they could like ask the question like a bit differently or in a harder way, could they possibly just add more like line items for that first test?
You mean like more rows or more columns?
Yeah.
It's if I had to say, from my experience, the most you can get is 3 rows, 3 columns. I don't think that it takes too much time to do more, you know, and your exam is going to be what, 2 hours, and you've got that many learning units to cover. So it's very unlikely that, you know, it'll be more than 3 by 3. Yeah, does that answer?
Thank you. Yeah.
Oh, good question. Yeah. Yeah, because it does take time, I understand. But also you guys got to practice on this, okay? So the faster you get it, obviously, the better. Remember, 2 hours is a very short time. Like, you hardly have time to go back and sense check your answers. So speed is important. All right, so let's look at this question. An advertising agency wanted to establish the proportion of people who read a particular magazine, right, which is called sports news. And they want to check whether the readership is the same across 3 geographical regions. Okay. A total of 300 readers of sports magazines was randomly sampled. And from those 2 regions, this is what they found. Okay, so if you add up all the numbers in this table, it'll add up to 300. All right. And so what they're testing here now, this hypothesis, they want to determine, is the readership the same? So that means, are the proportion of people that read this magazine in the Eastern Cape the same as the proportion of people that read it in the Western Cape, which is also the same as the proportion of people that read it in KZN? So your H0 is your testing for equal percentage of readership. So I'm going to say pi E, pi proportion. The reason why I'm saying E is because Eastern Cape, but you could say 1 instead. You could say pi 1. There's nothing wrong with pi 1. All right. I'm just writing E here, so maybe it's easier for you to kind of identify what I'm talking about. So is the proportion of readership in the Eastern Cape the same as the proportion of readership in the Western Cape, which is the same proportion of readership in cases? But you could say 1, 2, or 3. Perfectly fine. Pi, pi, pi. Either way, fine. So that's your H0, okay? Now, my H1 is just the opposite. Now, I know what intuitively you might just say, then pi 1 might just, sorry, H1 might just be this. It's just the opposite, which is not equals to, and that isn't the case. Okay, so don't write this. This is not the case. H1 is just testing if one of them does. So that means, in other words, you could have these 2 equal other, but the third one doesn't equal that, right? And this is one of the possibilities for H1. So you don't need to write H1 mathematically. Fortunately, this will make it easier for you. You don't need to write any math symbols here. All you need to say is that one of them differs. Say at least one differs. That's it. Easy as that. Okay? That's your H0 and H1. So this is your step one that you just done. Now you can see that this step one is a bit different to what we did in the previous example. So if you look at the previous example, your H0 and H1 is in terms of just words, no mathematical symbols, etc. Compared to here, it is. Right? So that's your step one. Step one. Now everything else, step 2, step 3, and step 4 is exactly the same approach as what we did previously. Okay. Step 2, you find your rejection region. Find the rejection region. And the way you do it is exactly the same. All right. Remember, it's an upper tail test. Your rejection region is always in the upper tail, on the right. The size of that rejection region is given by your alpha, which is 1%, 0.01. And your degrees of freedom is found the same way using that formula r minus 1 to c minus 1. The number of rows you got is 2. Number of columns you have is 3. You substitute that into the formula and you get a value of 2, I think. Yeah, 2 again. And so now, if you go to your table in the back of your book, okay, and you find that rejection region, and remember now your alpha is 1%. So it's the fourth column. And your degrees of freedom is 2, so where that intersects is 9.21. That value is 9.21 in the table. So that's our rejection. So anything above that, we reject H. All right, step 3, it's exactly the same approach as what we did earlier. So instead of doing all of the workings, I'm just going to copy the results. And I've even laid it out for you here. The working is exactly the same as what we did earlier. Okay, you put your observed values. Here's your observed values, your F0. That's this column here. Your FE, which is this column. FE is this column here. And that, remember the formula for FE you did earlier? It's FE is given by your row total times your column total over your grand total. All right, and you do this for each one, and you'll get this column here. Now, I encourage you to do this as an exercise. So, obviously I haven't gone to detail on how to do it, but I showed you how to do the previous problem. The process is exactly the same here. So what I want you to do is, after you watch this video, I want you to try and work out these values using this formula here, like what I showed you earlier. All right, so you'd use this table for your observed values. You'd get your total column here. You get your totals here, your grand total as well, and then you can compute this column. And then the next two columns are exactly how I showed you earlier. Right? Get the difference, square them, all right, and then divide by FE. Now, once you've done that, you add up all these values in the last column. And if you add up all the values in the last column, you get a value of 7.595. I'll write in red. The last column is 7.595. We added that last column. All right. Now, based on this value, 7.595, and look at your rejection region. Do you reject H0 or do you accept H0? Can you write that in the chat? What do you think? Based on what we found from our chi-square test and what our rejection region is, do we reject H0 or do we accept H0? Compare the 7.5 to the 9.21. Very good. So we accept H0. But 7.5 is smaller than 9.2. So that means it falls in the acceptance region. That means it's on the left of 9.2. It's somewhere here, lower than that. We don't need to know where it is exactly. We just need to know that it's on the left of 9.2. Yeah, so we accept it. That means this is correct, H0, and that we don't lean towards H1. And so step 5 is just concluding in terms of words. You finish this problem by saying, at a 1% level of significance, right? We conclude that there is an equal proportion of leadership across the 3 provinces. And that's it. So you can see step 2, 3, and 4 pretty much follow the same format as what we did earlier. It's just your conclusion that's different. Step 5 and your step 1, how you write up your H0, H1. But the calculations are the same. And that is the chi-square test for independence as well as for equal proportions. I'm going to stop there and maybe just leave the floor open to any questions that you may have. Okay, let me know if there's anything that wasn't clear to you. Otherwise, we can call it. Okay, thanks everyone. So next week, what we're going to cover is the last part of Learning Unit 9. This is pretty much the end of the course. Next week, we'll finish it up by doing the chi-squared goodness of fit. Okay. How about the rejection rate? No problem, Ethan. I can do that. All right. So how do they get the rejection region? All right. So I'm going to clear up everything on the board. Okay. Yeah. Okay. So a chi-square test is always a upper tail test. Okay. And the rejection region is always on the right. Now the size of that shaded region is given by your alpha in the question, your level of significance, which is 0.01. So what you need to do is you need to look at your chi-square table in the back of your book, right? Which is table 3. I'm going to, if you turn to that, this is what you will see in your appendix. you go to table T in your appendix, just after the normal distribution table and after the T distribution table, you'll see this table here. Okay. Now, here in this table, you will see that the alpha in the diagram is pointing towards the shaded region. So that's what the size of the shaded region is, which is 0.01. All right. So now, if you look at the first row, you're going to look for where alpha is 0.01 in the first row. That is given by this column here. This column. There's 0.01, just like what we have here. Now, we know it's this column, but which row is it going down? Now, to determine which row, that's where we need our degrees of freedom. Yeah. That's your degrees of freedom given by this formula here, which is 2. It's your R minus 1 times C minus 1. So R is the number of rows you have. So if you look at how many rows you have in your table, it's 2. You have 1 row for no, and you have 1 row for yes. For your columns, which is C in the formula, there's 3 columns. So your C is 3. Because you have a column for Eastern Cape, Western Cape, and KZN. So your C is 3. So if you substitute your R and C into that equation, into this equation, you get 2. So that tells me what row I need to stop at, which is this row here, where DF is 2. That's your degrees of freedom. So where DF is 2, you travel along that row. And remember, we're going to use this column. So where it intersects, there's 9.21. So that's the value that we need for this axis, 9.21. Right? That's your chi-squared value. But that's what this table tells you. For any given alpha and a specific degree of freedom, it'll tell you what the value is, that axis. So that's how you get your rejection region. So anything about that, we reject H naught. And anything below that, we accept H naught. Okay, does that make sense? Does it answer your question? Cool. No problem. All right, everyone. I hope you're enjoying the course. You're pretty much at the end of it now. And yeah, I hope you're enjoying the content and not finding it too challenging. Yeah, we're almost at the finish line. By next week, you'll be done. All right. And we'll call it a night. Thanks for joining, everyone. And have a good evening. Chat soon.